Can you see me, guys? Is it working? Can you see me? Say. Can you guys see me? Say. Can you guys see me? Say. Can you guys see me? You guys be gay all the time. Can you guys see live subscription count? Can you guys see me? Sure. So guys, we have 17 minutes approximately to complete this LeetCode sheet, and then we go and do Codeforces. Okay. Is that fine? Does that sound good? Give a W, guys. You guys should be supportive. Otherwise, I can't do this shit for long. Right? It's not easy to do this shit. Yeah. Bro fallen down to CF, but it doesn't matter. Does it matter? It doesn't matter. Right. Should I apply some filter on this? Yeah, we can cope like that. Okay, we don't have time. If I don't do it, LeetCode problem of the day will be gone, right? It's an easy problem. So we'll do it quick and then we go to Codeforces, okay? Easy Codeforces and then we'll go to that. How many viewers do I have? How to see that? 12 viewers. Because it's greater than 10, I'll start for now, okay? So yeah, let me read the problem quick. I have to do it within 15 minutes. You are given 3 arrays of length and that describe the properties of n coupons, code, business line and is active. So we have 3 arrays that they represent the properties of n coupons, and each coupon may have code, business line and is active. Code of I, string representing the coupon identifier, okay? String representing its identifier. Business line of I, string denoting the business category of the coupon, okay? Is active, a boolean indicating whether the coupon is currently active. So this indicates if it's active currently, this indicates what is the business category, and this indicates coupon identifier. A coupon is considered valid if all of the following conditions hold. Code I is not empty, is non-empty and consists of written an array of the codes of all valid indices. We have to output all the codes of valid, sorted first by the business line in the order EGP, or this is alphabetical order, and then by code in lexicographically. So we put this string first and then we put this string code and then we sort them. It just works, right? Vector string, okay, temp for int n equals to code dot size of, for int I equals to 0, I less than and I plus plus, okay. Let's see the code. String C equals to code of I, okay. B equals to business line of I, okay. If is active of I, okay. If it is active, then what should we do? And we should also verify these things, right? So as good programming, I'll just write here a function valid code. It takes a code C and it returns if it is valid or not, okay. I'll keep it as for cat seen as either A less than or equals to C, either A less than or equals to C and C less than or equals to C and C less than or equals to Z, or 0 less than or equals to C and C less than or equals to 9. My arms are hurting, like my fingers are hurting doing this shit. Or C not equals to, or C equals to. So these are the good conditions, right? if not of any of the good, like this is the condition that we want to satisfy. If that happens, return false, else return true. Okay. Did I type business spelling correct? Yeah, I did it. Return b equals to one of this shit, or b equals to, or b equals to, or b equals to. That's it. Valid business. Wait, is my code not being visible because of the video? Guys, can you guys confirm? Why is it lag again? I mean, I have good internet in my home. I'm at my friend's home now, right now. Guys, subscribe, guys. Or all my viewers subscribe. Like 10 watching now. Like I cannot. Okay, 19 watching. Maybe that's true. I hope it's true. It's not about Streamlabs. It's not about Streamlabs. It's my Wi-Fi is not very good. Like in my home, in my place, I have like 400 MB per second. Confirm if you guys can see. Can you guys confirm if you guys can see? See the video, see me, and you guys hear me, but I just wanna know like if you guys can see the code or not. Let me know if it becomes better, okay? So is it fine now? I wanted to ask if you guys can see the code while I am showing the video. So is it fine now? I wanted to ask if you guys can see the code while I am showing. Yeah, so let's do it. If you guys can see the code, valid business of B and is active of I. If all of this happens, we push temp. First business order, next code order, right? And then we have vector string answer. We have to sort temp. And then we have to return the codes. For that, what would I do? For auto f temp answer dot push back of f of 1 return answer. So this is supposed to work, right? We have one more stupid condition that says is non-empty. So now let me submit it and then we go to Codeforces. See, it accepted. I got coins, bro. Did I get this coin? No, it's just the streak. This is for This is to stimulate my brain, I guess. Gold coin that sparkles over here. Great. But I need viewers, guys. Like I'm trying to solve difficult problems on live, but you guys don't seem to be seeing. That seems good. Okay, let's go to Codeforces. Someone was asking from 2200, right? I consider 24 as not that difficult actually. Yesterday I took longer time for no reason. I don't know why I did that. So what rating should I go, guys? Codeforces, yeah, we are back to Codeforces. So we'll write 26 to 29, okay. Because someone was asking 24 to 25, right? Don't ask me stupid questions, I'll just remove you if you ask such questions. Focus on the stream for now. Try to find them in other videos, okay. This, I was not able to do that somehow. I was trying some randomizations, but yeah, they're never working. I was trying some randomizations, but yeah, they're not working. Have I tried all these things? I thought I have half solved this one, but I haven't fully solved that one. Is this fine, guys? No, let me try to read problems from here, okay? Let's read some problems over here. To get some confidence, see, I have solved some problems. This I have solved very recently. This one I have solved very recently. It was just some permutations thing. So guys, you should not be scared, right? My videos are to remove your fear, right? And because my videos are to remove your fear, this I solved long back, I guess. Let's try 26 to 29 itself. Let's read more problems. Let's understand problems, okay? They're all good problems, likely. I don't like permutation black hole because I have seen a little bit of solution. Let's try this one, okay? Let's try to think about this problem. Let's try to open some other problems, okay? Let's just try them. Maybe this I have read this already. I don't like if I have read that already. Maybe let me open some other problem. So we will try to read problems and understand problems. We'll try to push ourselves a bit, okay? No, even I don't try it again. Even I don't try it. That's why my rating is falling down, right? That's why my rating is falling down. I'm not that good. So let's read this problem. Let's try to understand this problem, okay? Or should I go for easier problems? Because if I fail to solve, people won't see my streams, right? And the subscriber count is never increasing. Say guys, what should we do? Should I try here or should I go to any lower rating? 21 to 23, I think. Or 2200 is good. So what I will do is I will read some problems here and then I will go to 2200 if it fails. Okay, let's try this one. First, let's try this one. You are given 4 positive integers, C0, C1, C2, C3. We are given 4 positive integers. Each of them can be between 1 and 800. That seems nice, right? That seems somehow weird. We are given 4 positive integers. That's nice. Let n equals to C0 plus C1 plus C2 plus C3. Consider an array of n integers. So we are considering an array of n integers with x 0 less than or equals to x less than or equals to 3 appearing cx times. So we have this 0, 1, 2, 3 and then we have x appearing cx times. So what does that say? So 0 appears C0 times, 1 appears C1 times, 2 appears C2 times, 3 appears C3 times for any distinct permutation B of the array A. 1 minute, I'll just reply to someone. Guys, it's I'm trying to prove you that even higher rating problems are the same things. You just have to try more, okay? I'm not using outside big concepts, right? So don't lose. I mean, it's easy for you to not care about it. So yeah, if you guys cannot see, then let me know. Now let's read this problem again. All easy problems should be even easier, right? If this itself doesn't use anything. Now for any distinct permutation B of the array A, define its distinct permutation. See, we are trying to reorder it as we like. It has only these values. Define its oddness as this one. It's something, this is the oddness it seems. Your task is to count for each integer k from 0 to 2 times of n minus 1. So guys, we have to try it well. Like, don't get discouraged. Try this well. The number of distinct permutations of a with oddness equals to k. So see, we believe in our golden rules. They say something. They say something, but still we should be able to solve it. We have to believe that, okay? Can I open some other folder? See, we will believe in golden rules because now what does that mean? It's weird. We have a definition for oddness. We have to count number of distinct permutations for each integer k. Like these are all the possible values of this value, let's say. We should be able to split these distinct permutations based on their oddness, and you should be able to count all of them for all of that. That makes it like somehow the problem should be solvable, right? If you believe in golden rules, it doesn't use outside things. It uses this definition. Maybe it uses what the permutation is. It uses what bitwise OR is. It uses what low bit of x is. But it only uses these things, right? Do you guys get what I mean? I don't know why I make them. Okay, don't confuse me now. Guys, let's try to read this problem. Let's try to solve this problem. Yeah, you can say that, but golden rules are to solve a problem, not to perform well. Okay, I may not believe them under time constraints. Let me read this problem. Let me solve this problem. You're pissing me off a bit. Your task is to count for each integers. So B is a permutation of A. Okay, its oddness is. What are they doing? Low bit of adjacent XORs, right? Low bit of adjacent XORs. What are possible values of BI? BI belongs to 0 0 0 1 1 0 1 1, right? And we want BI XOR BI plus 1, and we want low bit of that. Okay. So BI is a distinct permutation. It takes values among these things, right? It takes values among these things. So it's a nice problem, guys, because sum of n over all test cases doesn't exceed this. N doesn't exceed this. So it's 800. You should be able to find whatever the C1, C2, C3, C0, C1, C2, C3 values are. You should be able to find it in some n square or n cube algorithm. Probably n square algorithm. N square into n, maybe. Such an algorithm. But you have to solve the problem logically, right? What about, you can solve the problem if, okay, is there a simplification you can do? Is there a simplification you can work on? Yep. maybe make C2 equals to 0, C3 equals to 0 and try to think of the problem. Okay, so now we have only 0, 0, comma 1. Okay, let's try to think about this problem. How does this take a value? Let's try to think of oddness. Okay, if you see oddness, what is it? You have to take bitwise, you have to take lower bit. Low bit is nothing but just the value now. If you take 2 bits, low bit is just nothing but bi XOR bi plus 1. Because there is only 1 bit, right? But what is low bit? Eight plus 4, right? Okay, low bit is the last one. Okay, it's either 1 or 0. So see, first we have to analyze oddness little bit. Okay, we have to analyze oddness little bit, and then we have to think about the what values can a permutation take, and then we have to group these distinct permutations into oddness value this, oddness value this, oddness value this, and so on, right? So how can we define oddness? How can we see oddness? Well, how can you simplify this? How can you see this in a better way? What is this? XOR of adjacent things, right? Okay, let's just look at some zeros, some ones, some zeros, some ones, some zeros, some ones. Whenever you have both of them as same, it will take 0, 0, 0. And whenever the things changes, then it takes 1. Right? And so on. Whenever it takes changes, it takes 1. And again 0. Whenever it takes 1 and then it takes 0. This doesn't seem complicated. So, 1 minute, let me think. What I was thinking was, can keeping C2, C3 as 0 affect the problem? Because they are 1, right? Can making them as 0 affect the problem? I don't think it affects the problem. Now we have to think a bit more. Guys, we have to just see the problem well. We have to believe, we have to try a bit harder. We have to try a bit harder, okay? Yeah, it can be either 0 or 1 or 2. Let's write that too. Here it can be either 0 or 1. I mean, if I make this, then it's 0 or 1. Is either 0 or 1 or 2. That's why oddness is less than or equals to 2 times of n minus 1. That's why we have to count that for all these things. Okay, we have to count that for all these things. What does that mean? There is a simple proof that oddness value so there is definitely something nice in this oddness. There is something nice. Somehow there is something nice in that oddness, right? So let's try to see if there is something nice in this oddness because you have to see the whole problem. Okay, there are different ways to rearrange them, and then there are different oddness values for each of them, and still you can say for this oddness, these number of distinct permutations are okay. If you're trying to do some kind of brute force, still you have to make some sense to this, right? Can you do always C0 times C1 times C2 times C3? Such an algorithm. Can you write such an algorithm? When C0 plus C1 plus C2 plus C3 less than or equals to 800. Okay, if brute force is present, then I don't like the problem much. Then we have to see how can you solve that. If brute force is not possible, then I can try to see is there a good way to do this? Is there a good way to do that? Okay, we have read the problem. Maybe we can see this in a nicer way, or maybe we can do brute force. If you are somehow brute forcing and trying to maintain structures and then go and add n plus 1 and then try to find it again, then I don't like it much. I should not say such things, but I don't know. Then I don't like it too much. Depends on 0 to n minus 1